Hello all, I am Dr. Pravas Anjanbal. In today's class, we'll discuss about the identification of context-free language. So how to identify a language is context-free or not? Before going to the identification of context-free language, first we'll discuss about a little push-down automata. Remember, the automata is associated with context-free language. The automata associated with context-free language, in short, it is also called as CFL. In short, it is called as CFL. Okay. In short, it is called as CFL. So the automata associated with the context-free language is called as push-down automata. So push-down automata is generally two types. One is DPDA, another one is NPDA. Non-DPDA means deterministic push-down automata, NPDA means non-deterministic push-down automata. Okay, so what is the meaning of deterministic push-down automata? We have already discussed about what is the meaning of deterministic push-down automata and the non-deterministic push-down automata in the just previous classes. Okay, but deterministic push-down automata means for one input, there are more outputs, or there are more outputs or more transitions. We can say like Q summation tau to Q summation tau to either here in DPDA. In case of deterministic push-down automata, always for one input, the output is always one, means only one operation. But in case of NPDA, the output is more, means for one input, the output is maybe one, maybe two, maybe three. Okay, so this is called as non-deterministic push-down automata. So the language associated with DPDA means deterministic push-down automata is called as DCFL, means deterministic context-free language. So the language associated with NPDA is called as NCFL, means non-deterministic context-free language. Okay, so every DPDA is called as NPDA, but every NPDA need not be DPDA. Okay, so similarly, every DCFL is called as NCFL, but every NCFL need not be DCFL. Okay. Next, now we will identify the context-free language. How to identify the context-free language? So generally, initially we have already discussed about the regular language. We have already discussed about the regular language, means how to identify a language is regular or not. If you don't know about the how to identify a language is called a regular language, how to identify a language is a regular language, just see my previous lecture, how to identify a language is a regular language. Okay, so the language, regular language means every language must be finite, means there is no memory. If there is no memory will be required, so this language is called as regular language. No memory. If one memory will be required, one memory will be required, one memory, or we can say like one stack. So this is called as context-free language. If one memory or one means stack will be required, so this is called as context-free language. If more than one memory will be required, more than one memory will be required. If more than one memory will be required, this language is called non-CFL. Non-context-free language means this language is not context-free language. Okay, now we'll see some examples how to identify the language is context-free language. This is the method. If one memory will be required, this language is called context-free language. If there is no memory will be required, this is called finite language, or we can say like a regular language. If more than one memory will be required, this language is not context-free language. Okay. So remember one thing, every regular language is called context-free language. But every context-free language need not be, every regular is called context-free language, but every context-free language need not be regular language. Okay. So now we'll see some examples. See. Okay, these are the three options. So first option is regular language as well as context-free language. Second option is context-free language but not regular. Third option is non-CFL, means this language is not context-free language. Now we'll see the first example. See, L1 equal to a to the power n, b to the power n, c to the power n. N is less or equal to 10. N is less or equal to 10 means this language is finite. This language is finite. Since the language is finite, this language must be regular. This language must be regular because every finite language is called regular. It is regular means it must be context-free language. So it is option A, means context-free language as well as regular language. So first language is option A, means regular as well as context-free language. Okay. Now we'll see the second question. L2 equal to a to the power n, b to the power n, c to the power n, d to the power n, n comma m greater or equals to 1. See, here there are two comparisons. Means same number of a's follows same number of b's and same number of c's follows same number of t. But there is no relation between them. Remember, but there is no relation between means n and m. But there is no relation between n and m. So this language is context-free. This language is context-free but not regular. Why? Because it requires one memory. So here we can also construct the push-down automata for L2 language. How? A will push here, push A and pop B. Here push C and pop D. Okay. So A will push, B will pop, C will push, D will pop. Here there are two comparisons, but there is no relation between n and m. So we can solve this question using only one memory. It is just like we can push and pop up. We can solve this question using push and pop operations, means push down automata. So this language is context-free language as well as, but it is not regular. So it is option B. See the third question. A to the power n, b to the power m, c to the power m plus n. M comma n greater or equals to 1. See here we will push, means we can solve this language 3. How? A to the power n, b to the power m, c to the power m, c to the power n. Here A will push, B will push, C will pop B and C will pop A. So we can also construct push down automata. That means this language is context-free language. Context-free language but not regular. So it is option B. Okay. The next question. L4 equal to a to the power n, b to the power n, c to the power m. N is greater than m. So here there are two comparisons will be required. Here there are means same number of pairs follows same number of bits, and here C means here number of n's and n must be greater than m. Here in this case n equals to n, and in this case n is greater than m, means there are two comparisons will be required, means two memory will be required. Two memory will be required because here n is relation, means n has a relation with m, but in this case in the second question n and m there is no relation between them. That's why we can solve. That's why we can solve using only one memory, means second question. But fourth question we must require two memory, means fourth case, in fourth case, because same number of edge follows same number of bits, and n number of edge or n number of bits must be greater than m number of seeds. Okay, so that's why it requires two memory. It's required two memory. So it is option C. Okay, means non-CFL. It is non-CFL. Okay, the fifth question. L5 equal to a to the power n, b to the power m, c to the power n. See here same number of edge follows same number of seeds, and m is also a relation with n because m is not equal to n, means it will require two comparisons. It will require two comparisons, means two memory. It will require two memory. So this is non-CFL. Non-CFL. Suppose one example is, I'm just writing one language, L equals to a to the power n, b to the power n, c to the power m, n m greater or equals to 1. Just compare 4, 5 and this language. In 4, 5, it is just like similar type of language or strings, but here there is a relation between, means n and m has a relation. Both are means relations, both has relations. But here there is no relation between n and m. In this case, there is no relation between n and m. So this language is context-free language. Okay, because there is no, because we can push a b will pop a and c will null move. C will null move. Okay, this language is context-free, but it is not regular. Okay. So next question, sixth one. Here a to the power n, b to the power n, c to the power n, d to the power n, but n is less or equal to 1000. N is less or equal to 1000 means this language, this is finite. Finite means it is regular. Finite means it is regular. Regular means it is context-free language. So it is option A. Next one, L7, a to the power n, b to the power m, n is greater than m. Here only one comparison. Here only one comparison or one memory will be required. So this language is context-free language, but not regular. But not regular. So it is option B. Eighth one, L8 equal to a to the power n, b to the power m, n is not equal to m. It is just, it will also require only one memory because n is not equal to m. So it will require one memory. So it is context-free language but not regular. So it is option B. Ninth one. See, similarly here a to the power n, b to the power m, n is equal to 2m. Means here only one comparison will be required. Only one comparison, or we can write like this: a to the power n is like a to the power 2m, b to the power m. So only one comparison will be required. So it is option B, means context-free language or not regular. Okay. Next question, 10th one. Here a to the power n, b to the power m, n is equal to m square. we can also write like this: am square bm. Okay, am square. Remember, in this case means question means language 9 is in arithmetic progression. N equal to 2m, it is just like arithmetic progression. If language is in FE, means arithmetic progression, it must be context free language, but it is not in FE. If it is not in FE, so not in FE means arithmetic progression means either harmonic progression or geometric progression or factorial etc. It is called as non-CFL. Since it is in geometric progression, so it is non-CFL. See 11th language, a to the power n factorial b n factorial. Since it belongs to factorial, so it comes under C. C means non-CFL. Similarly, question 12, n is less or equal to 100. N is less or equal to 100, but it is finite. It may be means the language may be exponential, may be factorial, may be geometry progression, whatever it may be, but the language is finite. Since the language is finite, it is called regular language. Regular means as well as CFL. So it is option A. Then a to the power n, b to the power m. N is greater or equals to m, or n is less or equals to m. See here, we can take any one. Condition. If I'll take n is greater or equals to m, so this language is context free language. If we'll take n is less or equals to m, means this language is also context free language, because we can take any one condition at a time. Okay, so let I am taking a to the power n, b to the power m, such that n is greater or equals to m. So this language is context free because it requires only one memory. So this language is context free language. So context free language. So it is, but it is not regular, means option B. 13th question. L14 equal to a to the power n, b to the power m, n is greater than m and n is less than m. Remember, we cannot take both conditions at a time. Means if I'll take n is greater or equals to m, n is greater than m and n is less than m, so the language will be generated like L equals to empty language. L equals empty language. This is nothing means empty language. Empty language means it is regular as well as context free. So it is option A. Okay. So next question, 15th. L15 equal to a to the power I, b to the power j, c to the power k, d to the power l. So here I equals to k, j equals to l. Here I equals to k means ak bd, means j equals to l. Since there are two conditions are there. Since there are two conditions, means two memory will be required to solve this problem. And we cannot construct push-down automata for L15 language. So this belongs to C option, means non-CFL. Non-CFL. 16th question. A to the power I, B to the power J, C to the power K, D to the power L. Here I equals to L, J equals to K. What is the difference? Just see what is the difference between 15 and 16. Here also contains two conditions, here also contains two conditions. But in this means for 15th question, we cannot construct the push down automata. We can't perform the push and pop operations for 15th question, means for L15 language. But here we can construct push down automata. How? See here, A will push, B will push, C will pop B, and D will pop A. We can push. So that's why it is CFL, but it is not regular, means option B. But here we cannot perform push and pop operation, means in case of L15. But here in case of L16, we can perform push and pop operations. Means A will push, B will push, C will pop B, and D will pop A. But here all symbols are in arbitrary order, but we cannot perform push and pop operations. Okay, so we can solve L16 within one memory or within one stack, but here we cannot solve this, means L15 language with one memory. It will require two memory. Okay. Seventeenth, A to the power I, B to the power J, C to the power K, D to the power L. Okay, see here condition is I equals to K and J equals to L. See, just question 15 and 17. 15 and 17, what is the difference? Here we'll take both conditions at a time, but here we can take any one conditions at a time. Only one memory will be required. That means here it will require, means we can take any one condition at a time. Means either we will take I equals to K or we will take J equals to L. Means only one memory will be required. So this language is context free but not regular. So it is option B. But here we can, means for 15th question, we will take both conditions at a time. Both conditions at a time. Here is also we can take both conditions at a time, but we can perform push and pop operation because all symbols are in sequence order. But here all symbols are not in sequence order. So we will require two memory for this language, but here we can solve using, means L16 language. For L16 language we can solve using only one memory. But here since only one memory will be required, so this language is context free but not regular. Okay. Say 18th I equals to J, but J is not equals to K. J is not equals to K. So I equals to J, this is one memory. J is not equal to K, this is second memory. Means two stack will be required to solve L18, means L18 language 18. So it will require two memory, means non-CFL. So it is option C. See here, A to the power I, B to the power J, C to the power K, I not equals to K. Means one, here only one comparison, means one memory. So this language CFL but not regular. This is option B. A to the power n square. Since it is in, it is not, it means this L20 L20 language is not in AP. It is not in AP means arithmetic progression. So this language is non-CFL. Non-CFL means it belongs to C option. Then 21 means L21. AP means P is a prime number. It is also not in AP. Not in AP. So this language, it is C option means non-CFL. Okay, next one, a to the power n factorial. So it is not in AP. Since it is not in AP, so this language is non-CFL. Non-CFL means option C. Next question, 23rd language. A to the power k, but k is an odd number. A to the power k, but k is an odd number. Since k is an odd number, that means this language is regular. This language is regular. Regular means it as well as this language is context-free language. So it is option A. Next language, 1 to the 2 to 2n plus 1. This language is also regular. How it is regular? Just see my previous lectures, means the identification of regular language. Okay, 1 to the power 2n plus 1. This is in FE form or arithmetic progression form. So this language is irregular. Since the language is irregular as well as context-free language. Next one, language 25. Language 25 x is such that x belongs to A, B, C whole star. Here number of A's equals to number of B's and equals to number of C's. For example, we can take double A, double B, double C. Here number of A's equals to number of B's equals to number of C's. We can write ABC, ABC. Here number of A's equals to number of B's equals to number of C's. So since there are two comparison will be required, here first comparison, here second comparison. So that means two memory will be required, means more than one memory. Two memory. Two memory means this language is non-CFL. Non-CFL means it is option C. In this way, we can identify a language is context-free or not. Okay. So in the next class, we'll see or we'll read about the closure properties of context-free language. Context-free language means generally there are two types of context-free language, DCFL and NCFL. So we'll read about the closure properties of DCL as well as NCFL. Okay. Thanks for watching.